Okay, thanks. Well, let's move on to session 2. I can't see other questions there. So our second session is focused on the linkage of multi-generational data. And I warmly welcome Ms. Bhaval Chandaria from the Information Performance Directorate of the Western Australian Department of Health, Associate Professor Barry Milne from the Centre of Methods and Policy Applications in the Social Sciences at the University of Auckland, and also Lisa, I think you're going to speak in this session as well.
Beautiful, thank you, Merran. Let me just get the slides up. Awesome, thank you. Thank you for this opportunity to speak today and to hear from all the other presenters about some of the awesome work that's being done with multi-generational data linkage. So my name is Bhaval Chandaria. I'm team lead of the data linkage team here at the Department of Health in Western Australia. So I'm going to be talking a little bit more about the WA data linkage system, a bit of the technical side of how we manage the WA family connection system within our linkage system. But I'd like to start off just by acknowledging the traditional custodians of the land on which I live and work and on which I'm presenting today, the Whadjuk people of Noongar Nation, and I'd like to pay my respects to elders past and present. Okay, so very quickly, I'll give you a brief overview of the WA data linkage system, which I'll refer to as WADLs throughout the presentation. This is just to give you some context about how our system works and the data sets we have within it, which will help in your understanding of the family connection system within that. So the WADL system was established in 1995. It started off as a collaboration between the Department of Health, the University of Western Australia, Telethon Kids Institute and Curtin University. It's now housed and maintained by the Department of Health in WA. It started off with a linkage of primarily health data sets, so hospital morbidity emergency department. And it's gradually expanded to non-health data sets as well, including birth and death registrations. And it's quite massive now. We have over 70 data sets, many of which we routinely update and link. And this next slide is just to give you a bit of a brief overview of the variety of data sets we have within our system. So you can see there's a number of health data sets as well as other government data sets as well. That little box in the middle, the core data sets, are the data sets that we routinely link, the most frequently linked, and they're also the most frequently requested data sets. So the WA data linkage system is, as mentioned before, maintained by the Department of Health. It's a large, enduring linkage infrastructure. And all the data sets that comprise this infrastructure are probabilistically linked using primarily demographic data and advanced matching algorithms. So I won't go into that much detail about the matching process, just about the general process of linkage in the system. So as I mentioned before, these data sets are routinely linked to one another, and the WADL system is maintained and updated frequently. So it's a dynamic system and new records are constantly added, which means new links are constantly made. Existing links may be changed as we get additional information. Sometimes records are also deleted. So if we find out from a collection that perhaps they've got some duplicate records in their system, they'll let us know and we will delete the relevant records. So it's a constantly changing system. And this is very important to remember as I go through the presentation and talk a little bit more about the family connection system and some of the challenges that come with it. One thing we always like to mention when we talk about the WA data linkage system is that it's a database of links and identifying data. It's not a linked database, and it is not a linked repository of content data for analysis. So it only contains identifying data. And again, just to, sorry, I'm very quickly just going to run up to my screen. So just to,
So it's Merran here. We seem to be having a problem with the feed from the WA Department of Health, and we just give a few more minutes to see if we can get her back again. So I'm not sure what's happened to Bhaval. Maybe we'll give her another minute or two. And if we can't get her back, we might move on to presentation from Barry. Okay, well, I'm not sure what the problem is at the Department of Health's end, but I think probably the best thing to do would be to just go ahead with Barry's presentation, if that's okay with you, Barry, and then we can come back to Bhaval when she's got a chance to get her system back up again.
Yes, that's fine. Hello, everyone. Okay, I'm hoping you can all see that. I'm Barry Milne. I'm Director of the Campus Research Centre at the University of Auckland. And what I'm going to talk about today is the use of New Zealand's integrated data infrastructure, which is something I've been working on over the past 5 or 7 years or so, to construct multi-generational linkages. And I'll just initially talk a little bit about what the integrated data infrastructure is called. We abbreviate it to IDI, and then what's possible in terms of multi-generational linkages. Okay, so much like the system that Bhaval was talking about previously, this is a whole population of New Zealand. The New Zealand population is about 5 million people, although I'll talk about who's contained in the IDI, linking together of administrative data sources at the person level. So health, benefits, education, justice, and a few other bits and pieces. 2 New Zealand censuses are in there. So you can track longitudinally over time what services essentially people have been using in different sectors. As well as being longitudinal, it's also intergenerational for reasons I'm about to go into, because with the birth records that are included in there, there's a parent 1 and a parent 2 listed there, which are typically the mother and the father, and you can link. So you've got that triad there of the child and the mother and the father, and there are links to these data sets for all 3, potentially. Okay, so what we've got here is a birth data set, which is dating back to 1848, the Birth, Deaths and Marriages Act in New Zealand, 1848. And there's unique IDs there for the child and both parents, where both parents are recorded. There'll always be a parent 1, or typically the mother recorded, mostly a father, but not always the case. And with the birth data set, there are other potential ways you could try to do multi-generational linkage with this data setup, by looking at, for instance, family units identified in the census, and also there's some relationship data in benefit data sets and child protection data sets, but for just the clients of the Ministry of Social Development who run the benefits and the child protection data set. But the birth data set is probably the only one where you can get a full population of births, at least, although I'll go into how that doesn't cover the full population of New Zealand necessarily. So these records have been fully digitized since 1985, and there's a handful of them digitized prior to that, but digitization became routine in 1985, and what the Department of Internal Affairs, which is the organization that provides these data, is doing with a bit of financial support, is looking to digitize back further so we can get more of these multi-generational links. Parental dates of birth have been collected since 1972. Prior to that, there were just ages collected, and because this process uses linkage, both deterministic and probabilistic, we suspect that it's very unlikely that you get linkages prior to when we have dates of birth data for the parents. A key thing to note here is this will miss children not born in New Zealand, so it won't be possible to get intergenerational linkages for those children. And of course, children who have parents that weren't born in New Zealand, there's only so far back you can go. You might be able to link for their parents to specific data sets, but not a generation back further. And just a note on New Zealand there, that at the last census, 27% of the population were, of the sort of static population at that point, were born overseas. So you are still missing quite a chunk of the population. Okay, so how does it work here? So what we've got, to put the IDI together, they created a concordant spine, which is supposed to get an ever-resident population. We've got people born in New Zealand since 1920, people who've paid tax in New Zealand since 1999, and people have arrived in New Zealand and get a visa stamp for arriving since 1997. And that, when you put those three together, you get about 10 million individuals. So that's about double the current New Zealand population, because we've got people who have lived in the country, and also people who have lived in the country and died, making up those 10 million. So it's not a way, I should say, to get a population denominator for the country. You have to use other methods to do that, but it's an ever-resident population. Because of that concordant spine having bursts in it, children born in New Zealand are automatically included. So we've got the first part of getting the multigenerational linkage. Parents of children who are named on the birth records are linked both deterministically and probabilistically. So what we've got here is where a parent's listed, they go and try and find them already in the spine, or if they're not found in the spine, they're added to the spine. In terms of the linkage, most of it is deterministic, based on, well, not most of it, sorry, nearly half of it is deterministic based on sex, date of birth, and name. And the remaining is done probabilistically, where for the most part, they've got various passes that they go through. This is done by Statistics New Zealand, I should say, who maintain the integrated data infrastructure. They'll block on sex and date of birth and link on first and last name. I think that gets 56 of those 57%. And then they've got other methods where they block on different things. Their estimates of false positives in the entire birth data set is around about the 0.3% mark. And work that we've done as well kind of coheres with that, suggesting it's between 0.1 and 0.5%. So pretty good, but not perfect. And what I've done here is showed you the extent to which you can link a mother, which, as I say, is mostly the parent ones, and father, listed as parent 2 in the birth data set, to the spine. So in other words, if you've got a child born in a particular year, and they've got a mother listed on their birth record, what's the probability that you'll find them also in the spine, and therefore enable linkages back one generation to all the data sets that exist in the integrated data infrastructure. And you can see clearly here some of the points I made before, where we've got pretty solid linkage, near complete, back to 985, where there's been deterministic linkage. And then there's some linkage for some records between 1972 and 985, but only around the sort of 30 to 45% mark. And then prior to that, you're virtually getting no linkage at all, where they weren't really able to link the parents because they only got age information for them. In terms of being able to link back across generations, I've looked at this for various birth decades, but it's focusing on the most recent birth decades where we could expect to get the most linkage. And what I've done here is looked at where we've been able to also find a parent 1 and a parent 2, typically the mother and the father, also in the birth records. So not just that could they link to the spine, but can we find them themselves in the birth records? And you can see you're finding about 2/3 or so, which, given the number of children born, or number of people in New Zealand who were not born in New Zealand, that makes quite a bit of sense. But going back 2 generations, you're still getting reasonable linkage there, around about 1/3, and you're getting a handful going back 3 generations, but it's starting to starting to dwindle away to nothing because of the digitization only going back to 1985. Another impact of not being able to link people who are born overseas is you get quite stark ethnic variations. So what I've got here is, these are foremost common ethnic groupings in New Zealand: European, Māori, Pacific, and Asian. So these are the number of children born. And just to point out here that it's possible and very common actually in New Zealand to identify with more than one of these groups. So if you add up those percentages, you'll get above 100%. And the extent to which you'll find 0 in red, 1 in blue, or 2 parents back in the birth record. So you've identified a child born between 2011 and 2019. Can we also find how many of their parents can we find in the birth records as well? And you'll see big differences there where, so Asian New Zealanders, for instance, it's relatively very unlikely to find 2 parents in the birth records, and quite uncommon to find even 1. Whereas for the Māori population, and closely followed by the European population, virtually all, you can find at least 1 parent in the birth records. And that flows through when you try and track back 2 generations as well, where, for instance, for the Māori population, you can find a decent number of grandparents who are also born in New Zealand. 20% you can find all 4, 40% you can find at least 3, etc. But for Asian children, less than 10% where you can find even 1. Okay, so just to summarize this, with the integrated data infrastructure, intergenerational and family links are available using administrative data, and it's based on the births data set. And because of that, it misses people outside of New Zealand. Parents and children are linked deterministically and probabilistically at a sort of 40-60 ratio with low rates of false positives. It does allow, at least for the most recently born cohorts, to the generation of intergenerational links, but the linkage will vary, will be differential by ethnicity and other factors as well. I've looked at it by neighborhood deprivation, and you also see a gradient there where more deprived neighborhoods, you see slightly more links. One thing I didn't show on a slide, but we have looked at, is that through these intergenerational links, you can identify siblings as well. And we've written, we've written 1 paper doing a sibling analysis using this type of method. In any 3-year period, and I was looking at it for a 3-year period for a specific reason about how many siblings we would get if we were to fund digitization of 3 years worth of data. Approximately 20 to 25% of births can be linked to a sibling in that period. So where you've got 9 or 10 years, it's very common to find a sibling in there and have good numbers for doing sibling analysis. Thank you very much for this. Just a big thank you to the people at Stats New Zealand who've helped with this work, Michael Alsbach and Anna Lynn, Eileen Lee, who did the analysis for the intergenerational linkages, Andrew Spall, who you'll hear from later, and Shree Gibb and Craig Wright, who've helped a bit with looking at linkage bias and also the links that can be undertaken with birth records. Thank you.
Okay, well, thanks very much, Barry. That's been very interesting to hear a little bit more about how the IDI is actually set up in New Zealand and how helpful it is for doing family linkages. Now, I think we've got Bhaval back online, so we'll just see if we can get her presentation back up. So, Bhaval, are you there?
I am, yes, my apologies. Had a bit of technical difficulties, but I'm back and I will pick off where I left off.
Excellent, thanks.
Beautiful, thank you. Great, all right, I'll get straight into the family connection system. I'm just conscious of time. Thank you for your patience. So the family connection system, it was a family connections project that actually started in 2003. It had the aim of creating and storing electronic links between genealogically related individuals resident in WA using information recorded on birth registration. So very similar to what we just heard about in New Zealand. Initially the project focused on birth registrations going back to 1974, which Amani touched on early on. But a later phase actually incorporated newly digitized records that went back as early as 1945. So our family connection system now actually allows us to go up and down multiple generations for people born in WA. And as you can see on the screen there, it also now includes midwives notification system records. So basically the family connection system is created using information recorded on original birth registrations and midwives notifications. These are data sets where every record relates to an event which identifies multiple related people. So this slide is just kind of showing you a different way of looking at that. So basically with birth registrations, you get information about the baby, of course, and the parents, so mother and father. And with the midwives notification, you get records about the delivery of the baby, information about the delivery of the baby. So you have information about both the mother and the baby. So we use information from these two data sets to create separate deterministically linked records for each related individual, and then to link any additional records such as hospital morbidity to the chains of these individuals is where we would perform our standard probabilistic linkage. This is just a slide we'll work through to show you kind of how we can get some of these connections, and as I mentioned before, how we can get multiple generations within these connections. So basically by connecting parent-child relationships up and down the family tree, we can identify other relationships, down to grandparents, great-grandparents, if they're there, cousins, full and half siblings. We can also sometimes determine and aunts and uncles. So in this example, if we start off with this icon here for Jane, we can see that she has her own birth registration for her own birth, which tells us that her parents are John and Sarah. She also has a midwife's notification record for her birth, which again confirms her mother is Sarah. We can see that Jane has a midwife's notification record where she is a mother to Michael. And so from these records, we've already found Jane's parents and her own child. For Michael, we can see there's a birth registration where he's the father to a child, Julia. And so now we can also find Jane's granddaughter. And if we go up from Julia, we can go up to see her great-grandparents in John and Sarah. Likewise, again, with with Jane's mother, Sarah, we can see she has her own birth registration where she was a baby. And that tells us that she has parents, George and Agnes. We can then see that George and Agnes also have a birth registration where they're parents to another child, Philip. And that then tells us that Jane has an uncle, Philip, a maternal uncle. And so we can also see Philip has his own birth registration for her child, Stephen. That tells us Jane has a cousin, and so on. So depending on the records that are available, we can actually make quite a few of those connections. For your interest, we have had a small number of research projects come through that have requested just about all of these relationships, so quite complicated levels of relationships, up to grandparents and cousins and siblings and half siblings. But the most frequently requested connections are usually parent, child, and siblings. With that, I do also want to touch on, it has been touched on previously, but some of the challenges and limitations that we experience with family connections and the data that we use for family connections. So one is that we don't receive any information about adoptions. So this includes step, local, overseas adoptions, nor do we receive information about surrogacy. But occasionally when we're putting together an extract for a researcher or a requester for family connections, we may find an individual who appears to have two different mothers based on their midwife's notification and birth registrations data. So basically the midwife's record might say their mother is this person and their birth registration might say their mother is a different person. Part of our routine processes when extracting family connections data is to run some checks to identify these cases and then investigate them. And we have actually found that in some cases, this situation appears perfectly valid, and we surmise that there are probably instances of either adoption or surrogacy, where the woman who delivered the baby, i.e. the woman on the midwife's notification, is not the woman registered as the mother on the birth registration. So we don't know that for a fact, but from the information we have available, we can kind of make that assumption. And in these instances, we usually then leave it to the researcher or requester. We inform them that we've come across these cases, and they then determine which mother, so which record they want us to treat as the mother for their extract, which usually they make the decision based on whether they're interested in looking at biological, or social aspects. One of the other challenges that we experience is with, again, this has been touched on slightly before, is with some of the changing family structures that we see, which make it difficult to clearly identify paternal and maternal siblings. So currently the birth registration form allows for women in a same-sex relationship who have undergone artificial fertilization to be recorded. And information on the form is actually collected as either parent 1 or parent 2, where previously it was collected as mother or father. And so this can cause some issues in our system, where parent 2 is then automatically marked as a father, but is in fact a mother. But again, this is where we use some of our additional linked information to try and investigate these cases and try and identify the sex of that individual. But again, it is worth noting that data quality and validity does vary. So sometimes the sex field may not be entirely reliable in other data sets as well. This is a newish challenge that we are coming across, and we are in the process of looking at ways to adapt our processes so we can better handle them, and we can allow changing family structures to be better reflected in the data that's requested. Another kind of challenge that we experience is with father's details changing on birth registrations. So this can include either complete removal of the father's details, or sometimes the details are changed to an entirely different person's information. So part of our processes with birth registrations linkages is we do get corrections. So any records that are corrected do come through our system, and we have a process in place where we check what information has been changed, and if it is either all the demographic information has been cleared, we remove that record from the chain it is currently linked in, because it no longer contains any information. Or if it has changed to a different person's information, we again remove that record from the chain it was in, and we try and find the new correct link. And finally, one thing worth noting is that our family connection system only includes births that are eligible to be registered in WA, or with midwives notifications, it's only children born in WA. So this kind of ties in with one of the previous questions about information about migration. Unfortunately, we don't really capture that sort of information currently. Great. I won't run through the summary. I'll just leave that on the screen for you to have a look through. And I just also want to take this moment to thank all of you for your time, but also to acknowledge and thank everyone before me who's actually helped develop the family connection system to what it is today. It's a service we're very proud to be able to offer to researchers and users of linked data. Thank you. I will stop sharing.
Thanks very much, Bhaval. We have a couple of questions, but we'll hold those to the end of this session, the presentations in this session. So now hand over to Lisa for the final presentation in this group.
Yeah, and we're a bit behind because of technical details, Merran. What I would suggest is, because Amani and I have covered some of the key points in that opening presentation, that I would rather turn it to questions about this session so that we can stay on time. Okay. Okay.
Well, thank you very much, Lisa. That's a very helpful suggestion. So some questions here. There was one from Stacey, which is for incoming data. Do you link it to one specific data set at a time, or do you have core data sets you primarily link to? So I think that I'm not quite too sure who that is aimed at, possibly at Bhaval or Barry.
I can speak about the New Zealand situation.
Yes.
In the New Zealand situation, there's a core spine that I talked about, and everything and the nodes linked to that. So if you want to link health data, you need to link the health data to all the individuals in the spine, and there'll be some mislinks. And if you want to link benefit data, it's the same. There's no direct link between health and benefits. It's all via the central concordance table.
Okay, thanks. And then a question from Tony in the UK. I hate to think what time it is there. Have there been any changes to the WA data linkage system since the pandemic? For example, have new data collections been added?
That's a very good question. Thank you. Yes, actually, we've had an influx of data collections that have come in the last few years, 2 years with COVID, around the COVID reporting and contact tracing and testing of COVID data. That is actually been taking up a lot of our time and focus. We're doing that linkage frequently. It's our highest priority. But those data sets are not currently available for researchers. It's only used within department for reporting purposes.
Okay, thanks, Bhaval. And I think there's another one for you as well. It is a question around the midwives collection. And does it relate to multiple events for one woman, or is linkage needed to be performed across records to identify all the children for one woman?
That's a good question. So with midwives notifications, we do get on the one record information about whether it's multiple births, but we do need to perform the linkage across the different data sets to have for the one event where there are multiple births, and then to find any other children that the woman has had, we do also do separate linkages there.
Okay, thanks. And another perhaps related question. Where the records for an individual person in birth records, with these records, do you retain a tag that says the record was amended as it may not reflect the biological relationship? And I think you might have actually mentioned that in your presentation, Bhaval, so you might want to comment, but also Barry.
Yes, very quickly. So we do receive corrected birth registrations, but we don't get any other information besides, we can tell if a particular demographic fields have changed, but we don't get any additional kind of flags about, let me rephrase. So with the fathers, for example, we'll be able to tell that when someone previously was registered as a father, they no longer are, because the information on that record now relates to someone completely different. And so that's the level of the information that we can get with changes to birth registrations.
Okay, thanks. And Barry, have you got any reflections on that from the IDI point of view?
The answer is I'm not sure, and one of the reasons I'm not sure is I'm not involved in the linkage. I'm a researcher. I'm a couple of steps removed from that. So I don't know the extent to, but I can find out the extent to which changes are fed through. I expect they are. And I also don't know if there's a flag saying it's, what was the question? It's not the birth parent. My understanding is it's the birth mother should always be listed on the birth certificate. But again, I'm not the person who does it, so I'd have to find out to be definitive.
Okay, thanks very much. Well, look, I think that's been a really helpful session.